What if your story could ignite a movement? At New Solutions Network, we merge truth, resilience, and reinvention, fueling shows that cut past the noise and light up what really matters: human potential. Police, athletes, survivors, incarcerated folks, visionaries, we bring raw, real voices the world needs to hear. Want to share your story? Want to sponsor change? Now is the time. New Solutions Network, unlocking the future, one voice at a time.
Welcome, I'm Ian Jones and this is Sexy Science Time. I'm flying solo today. Natanya, unfortunately, is still recovering from the injuries she received during an accident she had falling from a stage in Salt Lake City. We're going to be continuing our conversation about mushrooms today. Before I start though, we need to have a little disclaimer. The statements I'm about to make have not been evaluated by the FDA. Nothing we say here, none of the substances we talk about, etc., are intended to cure, prevent, treat, or diagnose any disease. Today, we're going to be talking about cordyceps. It's a subject that usually comes along with a conversation about zombies, so we're going to get into that. Before we do, though, I would like to just give a little bit of a background on mushroom biology because it relates to The Last of Us and the zombie. I should also explain, for those that don't know, The Last of Us is a TV show. I think it's just come to the end of its second season now, and it's about a kind of fungus that infects humans and they become zombies, and then they pass on their disease by, obviously the way zombies do, by biting their victims. To unpack that, I want to go a little bit backwards and talk about the biology of mushrooms. And let's start off. Mushrooms themselves, those little dome-shaped things we see poking out of the ground, are the fruit of a much bigger organism. It's an organism that looks a little bit like a spider's web and a lot like the neurons in your brain. And can spread for hundreds and hundreds of square miles. I mean, these things can be utterly vast. It's mind-blowing. And it's also smart. Mycelium is an incredible material, organism. It can seek out food. It can back away when it senses chemicals or other substances in the ground that might be harmful to it. And it can, if it finds food, join up with other tendrils of itself and thicken up so that it can draw in more nutrients. Fungi are strange things, strange organisms. They are more like animals than people, than plants. And unfortunately, for most of the history of science, they've been lumped as this kind of side set of plants, but they're much more like animals. Their bodies are made of chitin, which is very similar to insects. Plants are made of cellulose. Fungi have to get their food from outside the way animals do, whereas plants create their own through photosynthesis. And they store energy the same way animals do. And in addition, they have much more genetic similarity with animals than they do with plants. Getting closer to the point about The Last of Us, the primary way that mushrooms spread is through spores. And if you look at the underside of a mushroom you buy in the supermarket, it's got all these little black gills in there. And if you leave that for long enough, the spores drop out of there and you'll see a cloud, a mess of kind of brown around underneath your mushroom, and that's the spores having dropped. In order to propagate, those spores have to land on something food-like and be at around 60 to 70 degrees Fahrenheit in temperature, which up until now has been great for us because our bodies being 96, 98, means that any spores that land on us can't actually grow. Now that we have global warming, unfortunately, and we'll get onto this later in my episode, there are now newer risks to human health, not from zombies, that are being created by this problem with the temperatures. Now, Cordyceps in the real world, it's currently there are many different varieties of it. And generally what you find in the wild is that they will infect an individual insect, caterpillar or so on. The insect may already be dead, but some of them actually take over while they're still alive. And The Last of Us actually refers to one specific kind of cordyceps, Ophiocordyceps unilateralis, commonly known as the zombie ant fungus. And this has been the basis for the show, but it only works on this one specific variety of ant. And I'm going to tell you a little bit about this because it's kind of gnarly. So what happens with this particular variety of cordyceps is that an infected ant will lose control. The mushroom will take control of its body, and over time, so a spore lands on the ant, and it starts to colonize. And we talked just a moment ago about mycelium. Well, in this variety of fungus, the mycelium actually permeates through the ant's body, and over time it starts to control the ant's limbs. It doesn't go into its brain, which I find particularly scary. So as the cordyceps fungus matures inside the ant's body, it has evolved this ability over hundreds of millions of years to actually control the ant's limbs. And so as the thing matures, this ant is slowly losing control of its body. And when the mushroom is ready to fruit, it does this really nasty thing. It takes the ant and it drives its body up a plant, and it goes to the underside of the leaf, and the ant bites on with its jaws, and that's pretty much a death grip. And at that point, the ant dies. And over the next few days, a tendril mushroom will grow out of the ant's head or out of its body, but usually it's out of the head. And at a certain time, when the temperature is right, this pops and spores fly out. But the clever thing is that this mushroom has figured out how to control this ant so that it dies at just the right height, at just the right time of day, for just the right temperature, so that the ant colony marching underneath gets sprayed with all the spores, and that's how it propagates. Now, what makes it different from The Last of Us is that it has evolved over hundreds of millions of years. I mean, just unimaginable timescales to do this one specific ant. And human bodies are much more complicated than that. All mammals are far too complicated to do that with. So for now, at least, we are safe from being turned into zombies by fungi. Cordyceps is a really cool thing. It's been known in traditional Chinese medicine for hundreds and hundreds of years, and it's got a whole bunch of bioactive compounds in there, all these clever little chemicals that do things inside the body which studies have shown have certain benefits. Again, I've got to be careful here with my NDA disclaimer statement. So Chinese medicine practitioners will prescribe it. I don't think that's the right word, but I'm going to use it anyway with caution, for increased energy and stamina. It makes cell energy production and usage more efficient, according to studies. It may help boost the immune system. It has allegedly anti-inflammatory, antioxidant properties, so may be good against cellular damage, aging kind of things, and may have some anti-aging, anti-cancer benefits as well, and may inhibit cancer cell growth, which is kind of fun. So in summary, no fungus can be spread by biting. Mushrooms don't bite you. Just as a little aside, the only way obviously that you can get sick from mushrooms is by eating poisonous ones. But you can actually touch poisonous ones with no harm effects at all. And practiced mycologists can even identify even toxic mushrooms by doing a little bite, chew, and then spit just to get an idea of the flavor, because that, again, is not harmful. So again, still, nobody got turned into zombies. The real threat, though, from fungi is through global warming and a number of fungal species that are now becoming more prevalent because of global warming. One particularly nasty one is Candida auris, which is common in hospitals, or not common, but can occur more likely in hospital settings. Unfortunately, global warming is now training mushrooms which have, for the last 100 million years, 200, 300,000 million years, whatever, to grow in temperatures of 60 to 70 degrees. But now our temperatures are starting to rise a little bit. More and more fungi are becoming used to those temperatures, and we're getting closer and closer to our own natural body temperature. And that's a bit of a problem. And so things like Aspergillus, actually the fungus that was the Tutankhamun's curse. So when they opened Tutankhamun's tomb in 1912 or whenever it was, that a lot of the people got sick. So that fungus is attributed to be the cause of that. And the main infection route for infection is typically inhaling spores. We can't do a lot about this. I mean, obviously, we could choose not to eat a toxic mushroom, but the spores are in the air all the time. You only have to leave a pot of cream cheese out for a day, and you'll start to see fungal colonies forming on it already. So the atmosphere is laden with them. And as the climate gets warmer, more and more of those spores pose a risk to us. And those typically come in the form of lung infections. And also because we're using fungicides in hospitals and in agriculture, they are learning to be more resistant to attack as well, which obviously leaves us more vulnerable. That's really where I want to kind of draw the line. And we are just coming up on the end now, but I want to finish with a little happy. I love mycelium. Mycelium for me is the real star of the show. Mushrooms are great, they're fruit, but you can't have those without the mycelium, and it does all this amazing stuff. I mentioned that it can cover hundreds of square miles. It interconnects plants and trees and can be used to transport nutrients between them and possibly even electrical signals. So there's some kind of communication going on through that as well. I've already mentioned that it's very clever at finding its way under the ground towards food and away from harmful areas. One of the other really cool things it does, because it's evolved over hundreds of millions of years, if not billions of years, it integrates with plants and trees to the point where it goes inside the cells of the roots of the trees. I mean, they are bonded to each other, and through that mechanism, obviously, the tree can then share its nutrients with its siblings or its children and other things. And there have been tons of studies to show how these chemicals interchange over significant distances. The other important thing about mycelium is that it is there as a decomposer, and it's the primary way that any nutrients that were bound up in the living thing that was walking around get returned to the earth, because these break it down and through their enzymes pass these nutrients back into the soil. And my favorite thing of all, and I'm going to leave you with this, is that the mycelium has been trained, particularly with oyster mushrooms, to break down toxic chemicals. And there was an experiment that Paul Stamets did where he used his mycelium, and two other companies had other kind of toxic remediation techniques. And they had a pile of oil-soaked mess, contamination, and the three different people had to try and decontaminate it. Paul Stamets used the oyster mushrooms, and they were the only thing that managed to break down all the oils and really returned that pile to a biological ecosystem, to the point where other insects and animals could actually now grow. And there's another famous experiment where they grew it on cigarette butts. And for anyone that knows, cigarette butts take thousands of years to break down because of the asbestos in the tips, whereas, yes, indeed, the mycelium crushed it. Thank you for listening to Sexy Science Time. I'm Ian Jones.